Hi, today's lesson is on coordinate geometry. We are all familiar with coordinate geometry. It's a method of plotting lines, curves, shapes, and other geometric objects on a coordinate plane. Let's understand first what the coordinate plane is made up of. So we've all learned the number line. The number line has a 0, which we call the origin, and the numbers go to the right when they are positive and to the left as they get more negative. So that's the number line. This helps me understand a one-dimensional system. But if I want to understand the plane, that is a two-dimensional system, then I need two number lines. So I have a number line working in the horizontal direction and one in the vertical direction. And they intersect at a point which I call the origin. I denote it by 0, 0. Let's put our tick marks. So the vertical number line, the numbers increase going up and decrease going down. Similarly, the horizontal 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, and so on. So suppose I wanted to denote this point. I would first move right 5 units and then I'd move up 3 units. So I write the 5 followed by the 3. And this ordered pair denotes the location of this point. You always move horizontally first and vertically next. The horizontal axis is called the x-axis and the vertical axis is called the y-axis. So any point, say this point, you'd first move horizontally left 2 units, that would be minus 2. Then you'd move down, say 3 units, that would be minus 3. So the coordinates of this point, let's call it B, would be minus 2, minus 3. So in general, the coordinates of a point are given by x, y, where x is called the, x coordinate and y is called the y coordinate. X is the distance you move horizontally to locate the point and y is the distance you move vertically to locate the point. So let's look at our coordinate plane again. X, y. So the axes themselves are important. How do I denote this point? Say it's 1, 2, 3. How do I denote this point? So to get to this point, I move 3 units horizontally. But I don't move vertically at all, so I move 0 units vertically. So this point is denoted by 3, 0 in its xy coordinates. How about this point? So this point, I don't move any units horizontally. So I have to write a 0 because I first write the x coordinate. In this case, the x coordinate is 0. And then I move up 5 units, so then I write 5. It's important to note that there is a 0 followed by a 5. This point is not equal to 5, 0. 5, 0 would be here. I move horizontally 5 units and then I don't move vertically at all. So, very simply put, all points on the x-axis would have 0 as their y-coordinate. So, the x-axis, 0 as y-coordinate. And all points on the y-axis would have 0 as their x-coordinate. These are important facts to know. What about points not on the axes? So, say a point here, or a point here, or a point here, or a point here. So a point here, let's call it A, will not have 0 as either coordinate because it's not lying on either axis. So any point here where both x and y are positive is in the first quadrant. Any point here where the x coordinate is negative while the y coordinate is positive is said to lie in the second quadrant. Any point here where the x coordinate is negative and the y coordinate is negative is said to lie in the third quadrant. And a point here where the x coordinate is positive while the y coordinate is negative is said to lie in the fourth quadrant. So the quadrants are defined as first, second, third, and fourth. So let's see our first example. The point R m comma n lies in quadrant 2. That means it lies here. This is the second quadrant. Here m is the x coordinate and n is the y coordinate. So since it lies in quadrant 2, I know that the x coordinate is negative and the y coordinate is positive. So m is negative and n is positive. So let's take values for it. So let's take m equal to say minus 4, n equal to say 3. So the point R becomes minus 4 comma 3. That will work. In which region is the point S and M? So S and M would be S3 comma minus 4. So I need to plot the point 3 comma minus 4. So I go 3 positive and 4 negative. And here's where I end up with S. So which quadrant is S in? First, second, third, fourth. So S is in the fourth quadrant. The answer is D. Important question. How did I go about doing it? I used the fact that R was in quadrant 2. So it told me that the x coordinate is negative and the y coordinate is positive. So I then picked values for m and n to make my life easy. I used those values to determine point S. I plotted point S and figured out the quadrant. If point P minus m comma n is in quadrant 1, then where is point Q m comma n located? So point P is in quadrant 1. Let's put P here. And its coordinates are minus m comma n. Let's give P some actual values. So I can take P as going, say, 6 units and then say 3 units up. So P being in quadrant 1 must be of the form 6 comma 3. Both x and y must be positive since it's in quadrant 1. So that leads me to conclude that minus m is equal to 6 and n is equal to 3. So that makes m equal to minus 6. A lot of you will now be confused. They'll say, hey, how can m be minus 6 if p is in quadrant 1? Because p's x coordinate is not m, it is minus m. And minus of minus 6 is 6, which is positive. Okay, let's move on to the question. Where does QMN lie? So Q would become m is minus 6, n is 3. So Q is at minus 6 comma 3. Where's that? I go 6 in the negative direction and then 3 in the positive direction. So here's Q at minus 6 comma 3. What quadrant is that? It's quadrant 2. The answer is B. Write the coordinates of the point P minus 2, 5 after. So let's plot minus 2, 5. Minus 2, 5. It's in the second quadrant. Reflection in the x-axis. So I reflect it in the x-axis. So I go to the x-axis and I move an equal distance downwards. And where will I get to? So I've moved down 5 units. So I move down a further 5 units below the x-axis. So what's the coordinates of this point? It will be minus 2, comma, minus 5. So the reflection in the x-axis gives me the point minus 2, comma, minus 5. Let's call it 1. Reflection in the y-axis. So to reflect in the y-axis, I first go to the y-axis. That means I cover a distance 2. Then I move 2 more in the same direction to get the reflection. So the coordinates of this new point are 2, comma 5. Let's call that P double dash. That's the answer to question 2. 2, comma 5 are the coordinates in the reflection in the y-axis. How about reflection in the origin? That means I go to the origin and I continue an equal distance away from the origin. And I end up here. So look at reflection in the origin. It's interesting. It's the same as reflecting first in the x-axis and then in the y-axis. Or reflecting first in the y-axis and then in the x-axis. So it's a combined reflection in both axes, one followed by the other. That's what reflection in the origin is. So where do I end up? So I end up at 2, minus 5. Because I've moved 2, 2 and then I've moved 5, 5. So here's your point, which is a reflection in the origin. We'll abstract these three notions. Write the coordinates of the point P A, minus B. Let's just make it simpler. Let's just call it P A, B. So the x coordinate is A and the y coordinate is B after reflection in the x-axis. So P A, B after reflection in the x-axis. What happens in reflection in the x-axis? Let's just recall. So A, B is somewhere here. What does that mean? It means this distance is A and this distance is B. If I'm reflecting in the x-axis, then this point is ending up here. I'm going down B units from the x-axis. So if this coordinate was B, this coordinate would be minus B. So it would become P A, minus B. The y coordinate is negated. The x coordinate stays the same. How about reflection in the y-axis? If I reflect in the y-axis, then I move a distance A and I move back a distance A. So this x coordinate is now minus A. The y coordinate doesn't change. It stays at the same height. So the answer is minus A, B. The x coordinate has been flipped. How about reflection in the origin? As we saw, reflection in the origin is equivalent to reflection in both axes. So both coordinates flip. So it will become P minus A, minus B. Distance formula. So let's see. I have 2 points. Let's say I have the point 7, 4. And I have another point. Let's call it 2, 1. Let's call this A and B. So I have 2 points A and B on the plane. I'd like to find the distance between them. That means I'd like to find the length of this line segment from A to B. Well, I need to construct something so that I can find this length. The easiest thing to construct is a right triangle. So let me construct a right triangle. Why is a right triangle useful? Because if I could find out these two lengths, the lengths of the two legs, then AB would be the length of the hypotenuse and I could use Pythagoras theorem. So the first thing to do is to find out this coordinate, C. What are the coordinates of C? Let's see where C is. Well, C's x coordinate is all the way to here, which is the same as the x coordinate away. Both of them have the same x coordinate, 7. So C's x coordinate is 7. What about C's y coordinate? We've moved up the same distance as B has moved up. That's a distance 1. So C's y coordinate is the same as B's y coordinate, which is 1. So now I know C's x and y coordinates. I know the coordinates of C. Let's see if we can find out the length of these legs. So this leg, AC, well, to go to C I've moved up 1 unit and then to go to A I've moved up 4 units. So this distance is 3. They're both on the same vertical line. So that length is the difference between their y coordinates. How about BC? Well, I moved 2 to get here and I finally moved 7 to get to C. So I must have moved 5 between B and C. Now I have the length of the legs. So let's find out the hypotenuse. The hypotenuse will be root of 3 squared plus 5 squared. And that will work out to be root of 34. So length of AB is root 34. And this is the distance formula. Okay. Let's do this with abstract values. So suppose my point A had coordinates x1, y1 and B had coordinates x2, y2. I need to find my point C. Here's point C. What are its coordinates? Well, I know this point has coordinates x1, 0. And I know this point has coordinates 0, y2. Because this is the same horizontal distance as A and this is the same vertical distance as B. So the point C will have coordinates x1, y2. It's the same horizontal distance as A and it's the same vertical distance as B. Now that I know C, I know the distance AC is the difference between their y coordinates. It's y2 minus y1. And I know BC is the distance between their x coordinates. So it's x2 minus x1. And since I want AB, I know by Pythagoras theorem, AB square is BC square plus AC square, which is x2 minus x1 the whole square plus y2 minus y1 the whole square. So AB turns out to be the root of this entire expression. So it's the root of the difference between the horizontal coordinates squared plus the difference between the vertical coordinates squared. Once you understand Pythagoras theorem, this is really a very simple formula. And here it is again. The distance formula. Difference in the x coordinates squared plus difference in their y coordinates squared gives you the square of the distance by Pythagoras theorem. So I take a square root of the entire thing to get the actual length. Given A 3, 7 and B A, 1, if the length of segment AB is 10 units, find A. So they've given me the length of segment AB, so I know I have to use distance formula. So I'm going to do it my way. So the length of segment AB is 10 units and I need to plot A 3, 7. So A 3, 7 is somewhere here and B A, 1. I need to find A, but I know the y coordinate of B is 1. So that's here. So I know B is somewhere here. Let's say B is here. B is A, 1. So the horizontal component is A. This is 3. I've given this length is 10. How was this length found? Well, the vertical height was found of this triangle. That was 7 minus 1 equals 6. And then the horizontal length of the triangle was found. That was A minus 3. The x-coordinate of B is A and the x-coordinate of A is 3. So the horizontal difference was A minus 3. So I know that A minus 3 whole square plus 6 whole square is equal to 10 square. So I know that A minus 3 whole square plus 36 is equal to 100. So A minus 3 whole square will turn out to be 64. How do I solve this quadratic? I'm definitely not going to open out. I'm just going to plug in values. So if I plug in 9, I get 9 minus 3 squared, which is 6 square, not happening. If I plug in 0, I get 0 minus 3 square, which won't give me 64. If I plug in 12, I'll get 12 minus 3 square, which is 9 square, that's not 64. If I plug in 11, I get 11 minus 3 square, which is 8 square, which is 64. So that does it. The answer is D, 11. So how did I do it? I plotted the 2 points and I figured out the distances and I solved. Of course, you can directly use the formula x2 minus x1 square and y2 minus y1 square. You'll end up with the same equation. But I prefer seeing what's happening because I might get a quicker answer. In fact, there is an obvious quick answer. Look at this triangle. The hypotenuse is 10 and one leg is 6. I know a right triangle with these legs. It's 6, 8, 10. Because it's a scaled up version of 3, 4, 5. And 3, 4, 5 is a standard right triangle. Therefore, so is 6, 8, 10. So I know if one leg is 6, hypotenuse is 10, that the other leg has to be 8. So I know that this leg has to be 8. When I'm actually done, I know that a minus 3 should be 8. And 11 is my answer. That would have been the quick way of doing it. Midpoint formula. The next important formula we're going to look at is the midpoint formula. So given a line segment, say going from A, let's give this point some coordinates, say 2, 4, to B, let's say 9, 7. I want to find the coordinates of the midpoint of this line segment, M. Let's call it XY. I want to find out X and Y. Let's complete our usual right triangle, find out lengths. So I'm going to first establish all the coordinates and their lengths. So I know that this is 2. I know that this point is X because it's the X coordinate of M. And I know that this point is 9. I know that this point is 4. It's the Y coordinate of A. I know that this point is Y. It's the Y coordinate of M. And this point is 7. It's the Y coordinate of B. Let's get this length. Let's give some names. So let's call this point X and this point Y. So what are the coordinates of X? The coordinates of X are X, 4. The coordinates of Y are 9, 4. What we notice about triangles AMX and ABY? Well, they're similar. That's easy to see. Firstly, I know that M is the midpoint. That's not important here, but M is the midpoint. I know that this is a right triangle and this is a right triangle. So the angle X and angle Y are both right angles. And both triangles share a common angle in A. So they both have two angles that are equal. So the third angle will also be equal. You can also see that they're corresponding angles so that they're equal. So all three angles of one triangle correspond to three angles of another triangle. So they are similar. What do we know about similar triangles? That the ratios of sides are equal. We're given that M is the midpoint. So we know that AM is half of AB. It's 1 by 2. AM is to AB. So we also know that AX is to AY is 1 by 2. And we know that MX is to BY is 1 by 2. I've just written the ratios of corresponding sides. Now it becomes simple to find the coordinates of X and Y. Let's use this ratio. AX over AY is half. But AX is the horizontal length here. So it's X minus 2. And AY is the entire horizontal length from A to Y. That's 9 minus 2, 7. So AX over AY is half is AX over 7. That means AX is 7 by 2. Obviously. So X minus 2 is 7 by 2. So X will be 2 plus 7 by 2. And you can figure out that value. Similarly, I'll use this ratio. I know that MX over BY is half. And MX is the difference in the Y coordinates. So that's Y minus 4. And BY is the difference of these Y coordinates. That's 7 minus 4, 3. So over 3 is half. So Y minus 4 is 3 by 2. And Y is 4 plus 3 by 2. So, important answers. X is turning out to be 2 plus 7 by 2. That's the X coordinate of A plus half the distance between A and B. And Y is turning out to be 4 plus 3 by 2. That's the Y coordinate of A plus half the distance between A and B, as it should be. Well, this is the usual way you see the midpoint formula. And what I did looked nothing like this. So let's see how they are actually the same. So let me derive this. What I did was actually the way one should work out midpoint formula. This is just a neat way they give the formula in the end. So I'm given a point A, x1, y1, and I'm given a point B, x2, y2. And I have to find the coordinates of the midpoint, which I'll call x and y. Let's again construct these values. So I know the entire distance A to B is x2 minus x1. I know this entire distance is y2 minus y1. Since this is the midpoint and since we discussed similar triangles, I therefore know that this distance should be y2 minus y1 by 2. It should be half the distance. And I know that this distance should be x2 minus x1 by 2. It should be half the entire length. Now it's easy to work. So if A is at x1, y1, what is M at? To get from A to M, I have to move a further horizontal distance x2 minus x1 by 2 and a further vertical distance y2 minus y1 by 2. I got to go here and here. So what's the x-coordinate of M? The x-coordinate of M, x, is x1 plus the further horizontal distance, which is x2 minus x1 by 2, which becomes 2x1 plus x2 minus x1, the whole thing by 2, which is x1 plus x2 by 2 as required. What about the y-coordinate of M? To get to the y-coordinate of M, I first go up to A and then I go up an additional distance y2 minus y1 by 2. So I move up to the y-coordinate of A, that is y1, and then I add y2 minus y1 by 2. That becomes 2y1 plus y2 minus y1 by 2, which becomes y1 plus y2 by 2 as required. So the formula makes sense. All we've done is use similarity and found out the lengths of this triangle. Once we know the lengths of the legs of this important triangle, we just add coordinates to reach M. We first go to A and then we move on to M. A minus 4, 3 is the midpoint of the line segment connecting M, 3, 7 and N, AB. A minus 4, 3. A minus 4, 3 is somewhere here. And it connects M3, 7. M3, 7 will be somewhere here. 3, 7. And NAB. So if A is the midpoint, N is going to end up somewhere here. I don't know whether it's going to go below the x-axis, but somewhere there. And I need to find A, B. Well, the easiest way to solve this question is to take values for N and check if that's the midpoint. So I know that minus 4 should be A plus 3 by 2, and I know that 3 should be B plus 7 by 2. Let's just plug in values for A and B. Let's try the first answer. A is 5. 5 plus 3 by 2, not happening. So now since I want a negative answer, I know A should be negative. So let me try C, minus 11. That's the only reasonable negative answer. So minus 11 plus 3 by 2 does give me minus 4. So it works. So C must be the answer. How do I know C is the answer without checking the y coordinate? Because C is the only one with a minus 11. So it has to be the answer. So that was a short introduction to coordinate geometry and two simple formulae, distance formula and midpoint formula, which are used very often. In the next lesson, you will look at graphing equations and functions.